Let's take a look at the questions on homework number 28. First, we start with a question about exponents. So if you don't remember the rules, you may want to scan through your notebook for the unit on exponents. There are only 3 things you can do with exponents. You can add them, you can subtract them, or you can multiply them. You add them when 2 things are multiplying each other. You subtract them when 2 numbers are dividing each other. And you multiply them when a power is being raised to a power. So for this problem here, it's technically a division problem. But we don't divide until we have changed our exponents. So when you divide, you keep the base the same and you subtract these powers. 6 minus 3. So 6 minus 3 is 3. So since it's asking us which number is equivalent to 5 to the 3rd power, we either multiply 5 times 5 times 5, or we use our calculator, and we use the power button, this little caret here. 5 raised up to the 3rd power. And we get 125, so that's how we select our answer. For the second and third questions, you're going to use your skills on solving equations by using properties of equality. That's where you do the same operation and the same number on both sides. Let's take a look over here. I've got a 5/3 x and a 1/3 x. This one is smaller, so that's the one I'm going to choose to use the inverse of. So I'm going to subtract 1/3 x from both sides, canceling out this and giving me a positive 4/3 x plus 5 over here. Now I'm going to subtract 5 from both sides, leaving me with negative 12 equals 4/3 x. Now some of you will want to divide by 4/3, and although this is true, we don't write our math like that because we don't divide by fractions, but if that's the only thing you know how to do, then that's what you should do. If that's the only thing you know, then that's what you do. You pick up your calculator, you type your fraction. For us here it is negative 12. Whoops. Use the negative sign. And then down here you would input another fraction. Now it's difficult for you to do on some calculators. Some of you don't have a calculator with this fraction skill. So if you don't, then you have to understand what dividing by a fraction is. We don't divide by fractions, we multiply by the reciprocal. We multiply by the reciprocal. So 4 and 4 cancel, 3 and 3 cancel, and now we have this math over here, which will be 3 times negative 12, 3 times negative 12, so you can use your calculator if you need to, 3 times negative 12, and then you're going to divide by 4. So negative 36 divided by 4 is negative 9. So the answer is negative 9 is equal to x. Now you can check your own work by substituting this negative 9 in where all of the x numbers are in the original equation. So you could put a negative 9 in here, and you could put this math in your calculator and check to see what you get. So this is how you use the check step. You type your fraction button, you type 1/3, you type the parentheses, negative 9, then you type subtract 7. Let's see what we get. We get a negative 10. Now we do the same math process on the other side. You type your fraction, 5/3, you type your parentheses, negative 9, and you type plus 5. And if you get the same answer on both sides, you know you did it right. That's called a check step. Alright, let's take a look at the third question. Over here, I'm going to distribute twice. And over here, I'm going to distribute twice. I'm going to pause for a second. We can continue with our inverse operations, or we can notice that we have matching variables, a negative 20x on both sides. And if that happens, you usually have a special solution, either called infinite solutions or no solutions. But you can only check whether it's infinite if it's a perfect match. And it's no solutions if the constants are different. So we're going to look at our constants here. We have a positive 8 and a positive 8. So if you have a match for your variables, it's one of these two special solutions. If you have a match for your constants, the answer is infinite solutions. So the answer to this question is infinite solutions because it's a perfect match. If you weren't paying attention and you just did the inverse operations, you would get something like this, plus 20x plus 20x. You would get a double cross out on both sides. And then maybe here you'd notice the match. Or maybe you kept going and you did this and you notice the match. Or some students do this. Divide by 8, get 1 on both sides, and there's a match. But at some point, you have to notice that it's a match and it has infinite solutions. Let's take a look at the Tuesday box, which asks us to identify if it is a linear or nonlinear function. So to be nonlinear means that you've broken one of these 4 rules, right? The variables cannot have exponents. Numbers can have exponents, but variables cannot. So, no variables with exponents. The second rule is no variables in the denominator. Numbers in the denominator? Fine. Letters in the denominator? Not fine. Nonlinear. No products of variables. No x's timesing y's. No products of variables. And the last one is no special symbols over the variables. No square root of x, no absolute value of x, nothing like that. You can have numbers in there. You can have the square root of 10. You can have the absolute value of 10, but you can't have variables inside these special symbols. So let's go take a look. Number 1, does it break any of these rules? Nope, it doesn't have any exponents with variables. It doesn't have any variables in the denominators, doesn't have any products of variables, and no special symbols, it's linear. This one over here, any exponents? No. Any denominators of variables? No. So this one is also linear. Doesn't break any rules. See this one? It broke the power rule. This one is nonlinear. This one has a denominator, but it's not a variable, so that's a pass. That passes the denominator rule. Doesn't have any products and doesn't have any special symbols, so this is linear. This one breaks the variable in the denominator rule, so it's nonlinear. And this one breaks the special symbol rule, so that's nonlinear. You have to memorize those 4 rules. Determine if the graph or table is a function. There's only 2 things you need to do. You either need to pass the vertical line test. If you're a graph, vertical line test. It's not called the line test. It's called the vertical line test. And for a table, you have to pass the no repeating x rule. No repeating x's, right? No repeating x's. So let's take our vertical line here and let's scan it down. It never touches the graph more than once, so that passes. That is a function. Over here, when I scan, you'll notice I touch the graph twice. I touch it up here and down here, so that fails the vertical line test, not a function. For the table, I'm looking at the x's, -2, -1, 0, +1, +2. Those are no repeats, so that is a function. It had no repeats. Turn the paper over. Pablo says that the relation shown is a function. Well, we just went over that. So let's look at our x values. Is Pablo correct? Explain on the lines below how you determined your answer. Pablo is incorrect. I have to answer the question. Pablo is incorrect. It is not a function because the x value of 2 repeats, and you have to add this last part, with different y values. So you can't just say it has a repeating x. You have to say that it repeats with a different y. All right, let's take a look at this equation here. This one requires us to combine like terms. 3x plus 5 equals 3x plus 12. Oh, I see it already. Matching coefficients. So I either have infinite solutions or no solutions. You have infinite solutions if the constants match. You have no solutions if the constants are different. So this has no solutions. Or you can write the null set, right? The null set. Okay, last box. Find the rate of change. Your brain should be thinking this, right? Y minus y over x minus x. So let's see, that should be a little tiny one. So this is our x1 and y1. This is our x2 and y2. We set up our giant subtraction fraction, and we go get our parts. y2, fill in the number. y1, fill in the number. x2, fill in the number. x1, fill in the number. So it looks like we're going to get negative 9 over 0. A 0 in the denominator is not allowed, so that means the rate of change is undefined. A 0 in the numerator is allowed, and the answer is 0. So don't get those two confused. And you have to write this word. If you write this fraction, but you don't write the word undefined, your answer is incomplete. You must interpret the 0 and where it is located. All right, question number 13. Identify the rate of change. The rate of change is this number in the coefficient of x position. But that only happens if your y is by itself, which our y is not. So I get rid of timesing by 5 by dividing everybody by 5. And now I can identify, using my eyeballs, the correct rate of change. The rate of change, ROC, is 2/5. Last two questions. Which of the following is not linear? Well, we just practiced that earlier. We go through our 4 basic rules. No variables with powers, no variables in the denominator, no variables timesing each other, no special characters over the variables. So this one is a pass. Oh, this is the wrong. I have two right answers here. This is not, and this is not. These are both not. All right, which of the following graphs is not a linear equation? And linear means straight line. This is the only one that's not. All right, that concludes the tutorial for homework number 28.